In our second example, they're giving us an initial salary and then a raise of $1,400 per year. And it says how many years will it take before your aggregate salary is this, okay? And so notice the aggregate salary, this would be A sub 1, and this right here is A sub 2, which notice as soon as you see this plus sign, that should remind you that this is an arithmetic sequence. So we're going to use all of the formulas that apply to arithmetic. And when I worked this one in class, second period, I realized that the wording is a little bad. It doesn't work out nicely. So we're going to say your aggregate salary is at least. Okay, so you'll see what I mean when I get there. So notice there we found A sub 1. We have the A sub 2 is that A sub 1 plus the common difference. So A sub 1 is 35,000. D is 1,400. Okay, so we need to figure out how many years. When they say how many years, that's our n value. And since this is a sequence in series, n will always be a whole number. Actually, it'll always be a positive integer, to be more precise. Since we look at the first term, A sub 1, A sub 2, and we kind of go from there. So we won't have a part of a year. So we're looking, okay, so when we're talking aggregate salary, that tells us that we're using S sub n. So I'm going to use the formula. Well, my two options well, notice this one, I don't know n, but I do know the total. I do know that the total is $280,000. So if I tried to use, sorry, that doesn't all fit on the screen. If I try to use this formula, I don't know n, I know S sub n, I don't know n, I know A sub 1, I don't know A sub n. That gives me two unknowns. So two unknowns but only one equation isn't going to work. So if I use this equation, I know this, I don't know n, I know A sub 1, I don't know n still, but it's the same variable as before. I do know d. So I'm going to want to use this formula right here instead of the other. So we have plugging in everything. Okay. So I don't like this fraction. I can either multiply both sides by 2 or check and see. When I distribute it through, notice this is going to have to multiply by, well, it's going to cancel with this 2. And then this 2 will cancel with that 1,400. So if I just distribute it through, I lose my fraction, and that makes life a little better. Well, this becomes an n minus 1 times this is 700n. I just multiplied this times here, and I'm going to distribute it through a little farther in a second. So here I am. Okay, and I notice that it's quadratic. This becomes plus 34,300n when I subtract away the 700, and then this, and it all equals 0. Okay, not gonna lie, this is kind of gross, but I'm gonna grab my calculator, and I can factor out 34,300 divided by 700. That's 49. And then 280,000, right, divided by 700 is minus 400. Okay, really gross, but now I'm going to utilize my calculator again. I'm going to go menu and come down to equation. And this is a polynomial, so I'm going to hit on polynomial, degree 2. And my coefficients were 1, 49, and negative 400. Okay, so it gave me Then n is approximately 7.127, or n is approximately negative, oops, sorry, you can't see it, negative 56.127 also. Sorry, there it is. Well, it doesn't make sense for n to be negative. We're talking terms in a sequence, and so that answer is no good. And it doesn't make sense to talk about a part of a term in a sequence. So if we want to look, we can see what we want to check. We want to check S sub 7, and we want to check S sub 8, and see which one gives us at least $280,000. So coming back here, I have, well, that equation was, did I clean it? Oh, let's see, we'll use this right here. That gets a little cleaner. 35,000 times 7. Or actually, let's do this. Let's take advantage of our calculator. I'm going to take 7 and store it as x. And so now I'm going to use this line here. 35, oh, too many zeros, x. Plus 700, oh, I could have used a different row, but oh well, minus 700x. So it's plugging in 7 for me. Notice that didn't get big enough. Now if I come back up here, and instead of storing 7, I store 8, that is now big enough. So the final answer becomes 8 years. Oh, haha, you can't see it. 8 years, yay!